Welcome
I will
back.
offer no help then.
No, I need help. Welcome back
Yeah,
to
no
day
help.
26 of LeetCode Grind. Solve or go home. 30-minute solve or go home. Alright, let's. I definitely need help. I don't think
No,
it's
no,
up
no,
to
I don't
shit.
think so.
Wait, why is this page unavailable? What happened? Oh, is it May already?
No.
Yo, why is it forcing me to click May? It's not May yet. It's still April
No,
28th.
no, 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 no. They're setting up May because it's
Uh,
close to the end of April.
yeah, they're trolling me.
You have to go
Okay. Wait,
find
how
the
come I'm only
April
at
one.
60%? I did like most of it.
Well, you
Oh,
joined a little late.
there's still another week left.
There's
Oh, there's two more. Okay.
and also they have bonus questions for premium members,
Oh, I
which
didn't even
none
notice
of us
that.
are.
Oh, okay. So they're adding like new stuff now. Alright, whatever. Alright, unique paths 2, okay? Robot is located top left corner of an M by N grid marked with start. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid marked by finish. Now consider some obstacles are added to the grid. How many unique paths are there? An obstacle and space is marked by 1 and 0 respectively in the grid. Okay, so wait, marked by 1 and 0? Oh, space is 0. Space means you can move through it, right?
Mm-hmm.
Obstacle means you can't. Okay, so you want to hit. Oh, to finish and start location is always the same location. Okay. So basically, oh, okay, so you're counting how many paths you can get there, right?
Right.
Okay, so I believe this was like a DP solution.
You can do it by a DP, and it's probably a good idea to do it by a DP.
The only thing is figuring out what you're storing into each square.
Right. So I would recommend looking at it without the obstacle first. So that's basically unique paths one.
Okay, sure. So yeah, just assume the whole array is just zeros, right?
Hmm.
So if you're
How would
doing
you do it?
that, okay, so in the 3 by 3 grid, you have one path where you can go uh, right, right, down, down. That's one path.
Mhm.
You got
Yep.
down, down, right, right. That's another path.
Mm.
You
Yep.
got down, down. Wait, no, no. We're down, right, down, right. That one works too.
Okay.
That's 3. Then you got the right, down, down, right. That's 4.
Mhm.
And then is that it? I think it's only 4.
No, there's two more.
There's 2 more. What? Which one is it? Okay. Um, let me write it down. So 3 by 3. Okay, so you got the uh, rights, rights, down, 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 right, 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 down, and then you can go down again and right. And you got the right, down, and then right down.
Hmm.
Then you got the other path, which was like down, right, down, right. Yeah, down works, down, right, yeah. And then it's probably another down path. Down, down, right, right, down.
That's correct.
Okay, yeah, so that's 6 paths. Okay, given that, given this stuff, how do you know, like, what do you want to store here? So basically, wait, are you kind of just storing a count for each square? Is like how many paths go through this square kind of thing?
Yeah, you can do that. In fact, that's probably the best way to think about this. If you, yeah, if you do that, then if you know how many paths go through a certain grid section, then then you just have to return the answer for the
The
last
last
grid
square,
section.
yeah, basically, right? Because then you're building the numbers at each index, and then when you so and then at the end index, the exit index, you should have the total number of paths that can get there, right?
Okay. Right. So I guess a quick question for you would be let's analyze some extreme cases, right?
Okay.
So what happens if you have a flat grid?
What is a flat grid?
Let's say it's 1 by 3.
1 by 3. Okay. So you're looking at like a 0, 0, 0 or something like that.
Hmm.
Yeah. So that's only one path
Why?
because there's only one way to go to the exit.
Right, because you only go right.
Yeah. Oh, wait,
Right.
actually,
So that
is
means
a 1 by 3 even a possible grid? Because then I thought that the exit has to be in the. Oh, the exit's just the last element of the grid, right? It doesn't. It
correct.
doesn't mean it's specifically at the bottom of like the. I guess yeah. So it's just
Okay.
the length index and the column and the row is the length of the index for both.
Mhm.
Okay, that's what it means. Okay, and start is always the 0, 0.
Right.
Okay, yeah, that's fine. Okay, yeah, so this is only one path.
Right. So now if we draw out the DP for each path, what would it look like? Sorry,
So,
the DP for each grid element.
so I don't think you need to store anything in the first index. That's where you start. So you just ignore that one, right? But you could, I guess, you can just put one there.
We could put a 1, sure.
Yeah. So then it would just translate to 1, 1, 1.
Okay. And same analysis for 3 by 1.
3 by 1. Okay, so that would be like 0, 0, 0. Okay, so in this case, there is also only one path.
Right.
So it becomes 1, 1, 1.
Okay. So now if you extend this to the 3 by 3,
Mm-hmm.
what should the you can already fill out five of the elements. Right.
Yeah, so it kind of looks like a 1, 1, 1, then 1. We don't know this one yet. We don't know this one. And then 1.
Okay. So now if we look at position 1 comma 1,
Yeah.
right? The first 0.
Yeah.
How do you get there?
How do we get there? So we can get there from the top direction or the left direction.
Right. And how many ways can we get there from the top direction?
One way.
Okay. And how many ways can you get there from the left direction?
One way.
So how many ways are there to get to that location?
2.
Okay.
So it's basically the sum of it's the sum of the ways you can get to the indexes that can get to it, right? So if its top is like 2 and left is 2, then you add them together and it's 4 to get there.
Right. Does this if you extend this does this get you the right answer for 3 by 3?
All right, yeah. So let's extend it. So if this one would be 3, this one would be 3 as well. This one would be 6. Yeah, that's correct.
Okay. And are you convinced that this works?
I mean, it looks like it works for 3 by 3. I guess I can try 4 by 4 or something.
Okay, so why is it that if you take the left value and you add it to the up value, then you have the total for that grid?
Because basically both those paths can lead to this. So however many paths you can get to that spot, that means you can all those spots can go to this spot as well. So that's how many. So basically, yeah. So if you can come from the top direction to here, then you that's how many paths you can get to this spot also. But then also there's other directions that can get here. So because of that, you want
Okay,
to add those two.
I think you have the right idea, but basically, I think you want to formalize it a little more, right? So let's say you have a path that goes to the one above you. What do you have to do to get it to your current position?
You said a path to get to the one above you.
Hmm.
What do you have to do to get it to your spot?
Hmm.
Well, you just go down.
Exactly. So whatever path went to the position above, you just append a down to it.
Yeah.
So that means every path that goes to the above position, if you append a down to that, that means you're in the current position, right?
Yes.
And same thing with the every path that goes to your left position, you append the right to it, and then you're in the current position. So that's why it's the sum of the two.
I see. And it's always the top index and the left index, basically.
Correct. Because right now we're limited to only those two directions.
What do you mean by limited to those two directions?
The robot can only move down or right.
Oh, that's why. Yeah. Okay, that makes sense.
Okay, okay. So now that this is the base solution, right?
Mm-hmm.
What happens when you have an obstacle?
So yeah, obstacle means you can't get to that path. So basically, you we just obstacle in the DP. We just leave it at 0. Basically, you're adding 0 to whatever your path is. Should be fine.
Yeah, that's one way to do it. You can set the value of the DP array
To
to
0 for
zero
all the
if you encounter an
obstacles.
obstacle.
Yeah.
But that affects your initialization, right? Let's say the obstacle is in the first row,
Mm-hmm.
and what happens? Let's say it's in position 0, 1,
Okay. So if you're saying
right? In your 3 by 3.
so you're
Then
saying
what would your DP look
there's a
like?
rock here.
Yeah, put up a rock there.
Okay, so if there's a rock there, that means we initialize instead to 1 and then 0, 0.
Exactly.
Yeah.
So okay, um, so as you surmised, if you any time you go beyond the obstacle,
You can't go beyond the
you can't
obstacle.
get there,
Yeah.
right? So um, okay, then I guess now comes the coding aspect of it.
Yeah, so when you're building your DP for the first time, right? Because you start 0, 0, you want to check to see if you can keep going, and then you just put ones all across the top row, right? And you put ones all across the row below it, as long as there's no obstacle. Once you hit an obstacle, you stop, basically, right?
Okay, that's fine.
And then once you finish that, then you look at the rest of the indexes and calculate it, right?
Okay, that's fine. So you're handling the first row and column differently, and then you're gonna loop through the rest.
Yeah. Is that fine, or
That's
is
fine.
it better to build
Yeah,
them all at the same time?
no, that's totally fine.
Okay. All right. So if I do that, I'm gonna do rows equals len obstacle grid. Except I can't spell obstacle grid. Okay, and then columns equals len obstacle grid 0. Okay, so for row in rows, for col in columns. All right, if I'm doing the first row first, I don't need to double loop. I just need the one loop. So I'm gonna check for row in rows first. If okay, I need a DP first. So DP equals believe it's 0. Wait, no, not 0. Yeah, zeros times rows, and then but then I need both of it. Can I just do like that? How do you initialize this to have the same
Oh, I see.
dimensions?
Uh, well, you can do 0 for I in range calls, for j in range rows or something, or you can just do 0 times calls, and then
That will get me
for
the columns, but how do I add the rows to it?
right, then you need an array for that.
What do you mean I
So
need?
for index in range rows.
Wait, what do I do after this? After this multiply?
Yeah, yeah, but you need that wrapped around a array.
Oh, so it's like this. For I in range rows?
Yeah.
Wait, so that's the syntax? It's just 0 times columns for I in range rows?
Right, so this will make a column dot length array of zeros for each row in rows.
Okay.
Right.
Yeah. Wait, I can do the opposite. Can I? Can I do for I in range columns and then 0 times rows, or does that not work?
But that's wrong, right? Because you'll flip the axes.
Oh, I see.
Because length of DP should be length of obstacle grid,
Yeah, yeah. But
which
then,
means they both should have the same number of rows.
yeah, yeah, I know. I was just so
You can do it. You can do opposite. You can do whatever you want.
so no. So this way it guarantees it is the same dimensions. Like, what is the logic for this one that does it properly?
Oh, so the logic here is that your for loop goes through every single row. So that means inside you're gonna have rows number of components.
Mm-hmm. But then, okay, so for each row you're building a 0 column, right? Is that what it means?
Yeah, for each row you're gonna have column number of elements that are all 0.
Oh, okay. Wait, why is it wrapped in an array then?
Because you need the array of it's the same type as obstacle grid. It's a list of lists.
Oh, okay. All right, wait. Let me just print it real quick. Um,
You can just do pass or something.
yeah. Oh yeah, this stuff is not optics code. Okay, yeah, that looks kind of right. It's more spaced out than the input, but that's probably fine, right?
You should give it another input. Change the input a little bit so it's not symmetric.
All
If
right.
you want to convince yourself.
Yeah, it looks fine. Okay. All right. So. Okay. So for the first row, okay, if obstacle grid. Wait. Yeah, obstacle. No. Rows is just the length. So this should be range.
Yep.
Okay, so if obstacle grid row no, it's so it should be 0. But row. Wait. I don't want to loop through all the rows. I just want to loop through first. So it's not really so it should be for columns, I think. So I'm doing the
You
row.
do both, right?
Yeah, but I'm doing this one first. So for column in range columns, 0th row, and then should be col. If this is equal to 1, then I just break. Else I set it equal to 1. That's a DP equal to 1. DP of 0 col equals 1. Yeah, because 1 is the obstacle. Yeah, 1's the obstacle. Okay, yeah. If it's obstacle, I'm done. Else I put this. Okay. Now I want to do the column. The column for row in range rows. Okay, so this one, I'm looping through every row, and I only care about the 0th column, so it should be, yeah, this should be fine. So if obstacle grid, and then this one would be row 0 equals 1, break, else dp row 0 equals 1. So those two loops should get me the first starting ones. Let me print that real quick. Just put pass up here to stop that code from executing. Oh no, what's not indented? This thing? Line 28. Oh, it's this stuff. So this step, so pass doesn't stop this. I have to comment it out. Okay, yeah, so it built this, and that kind of looks right. Yeah, it does. That looks right. Okay. So now that I have that, I know I need to start at index, I believe it's 1, 0.
Okay.
What index do I start at? So I have the first row done, and I have the first column done. So I look at that. I need to start at index, I would think is 1, 1. Yeah, 1, 1 is where I should start. But then the thing is, if I'm looping through the things anyway, it's gonna hit the whole array anyway. So I can just skip. It's like, how do I know what to skip?
Why do you have to skip?
I mean, technically I don't have to skip. I could just do the whole thing again. It's just, because then if it's out of bounds, then that means...
Oh, you'll never get out of bounds if you're inside of this range.
No, I mean, like, if your left and up is out of bounds, then you just don't
It won't be, because you're starting with 1, 1.
Yeah, I know, but then, okay, so let's say you start with 1, 1, right? You loop through to the end of 1, 1.
Mm-hmm.
Oh, and then you start with 2, 1.
Exactly.
Okay, so yeah, okay, so your array, you start in... Okay, so it should be for range row, and then it should be... This one should be 1. And then... column should be also 1. Yeah, because then if that forces it to start 1, 1, right?
Mm-hmm.
Okay, and then when it loops, yeah, and when it restarts the loop, it's gonna be at 2, 1. Okay, yeah, that should be fine. Okay, so in that case, okay, so right, so I have ones for, yeah, if it's zeros, yeah, that's fine, that's fine. Okay, so I can get rid of this. If no, there's no if needed. It's just obstacle. I guess no, it's dp dp of row column equals obstacle grid row column, and then this should be the one above. The row above is -1. The column.
Wait, sorry, what? Why are you using obstacle grid, not DP?
Oh, you're right. Obstacle is just my bad. Yeah, we don't.
No, obstacle grid tells you where the obstacles are, so you should.
Yeah,
check
but no,
that.
we already built that already. It's fine, right?
No.
Oh,
you have to
no,
check
there's
it.
still more obstacles. Yeah. Oh, yeah. That was just the first. Yeah, my bad. You're right. If. Okay, so wait. So if I'm checking for obstacles, if there's an obstacle, that means I shouldn't put anything in this one. I should just set it. If there's an obstacle in this current one, I should set it to 0. Yeah, and yeah, that's it, right? So because then if I put a 0 here, it's gonna affect when I build the DP to the right and to the bottom of it. So it should be fine. I don't need to specifically mess around with that. Okay, yeah. So if obstacle grid row col equals 1, dp row col equals 0, and then else plus dp, I think, so row -1 is above it, and then we want row and column -1. Yeah, that should be it.
Okay. Is line 26 and 27 necessary?
Line 26 and 27. What do you mean it's not necessary? We need to add this stuff, don't we?
Oh, no, you just changed it. Is line 24 and 25 necessary?
Oh, my bad. 24 and what was it? 24.
24 and 25.
Why is it not necessary?
What did you initialize it as?
What did I initialize? What row column? Oh, I see what you mean. If it's already zeros. Yeah. Okay, I see what you mean. So if it's not equal to 1, then just run the code. Wait, does Python have not equals? We have to do not.
Yeah.
All right.
Yeah, that's fine.
Yeah. Okay. So run this, and then yeah, I need to return. Believe it's dp -1 -1. Do you have to do it like that, or is it? Can I just do -1?
Yeah, that's fine. That's fine.
Yeah. So that one looks good. Which examples? Just another example. Okay, that one works. I think we're good. Just try this one. Yep, that looks good. I'll have a print here. Oh, I accepted anyway. Alright, cool.
Nice. Very good.
Nice. Now, unique pass 1 is super easy. It's just this algorithm, but you don't have to care about obstacles, right?
Yeah, in fact, you solve unique path 1 on the way to
Yeah.
unique path 2.
Nice, nice.
Oh, you got a supporter.
Oh yeah, I saw that earlier. I was like, thank you. I didn't say it.
Nice.
I don't know who that is.
That was good. Anonymous support. All right, cool.
Alright, thank you.
Yeah, I don't know if there's additional ones. There's extensions that I ask sometimes. Like, what happens if you flip the obstacles and make checkpoints instead?
What do you mean by that?
Like, instead of an obstacle where you cannot go through it, right? You might have something where, like, oh, you must go through it.
Oh, you're forcing people to go through it.
Yeah, it's like a waypoint or something, right?
Wait, does that change anything? If you're forced to go through there, the number of paths going through there is the same number, isn't it?
So let's say you have a 3x3 and you have to go through 0, 1.
Okay. Oh, so you're saying I cannot go bottom anymore. I have to go 0, 1.
Yeah, exactly.
I see. Okay.
So,
Well, in that case, you treat it as like, so if you have an obstacle there, I mean not obstacle, as a checkpoint there, right? So basically, if a checkpoint exists, everything on like the opposite side you just zero out, basically.
not quite, not quite. I think if you think about it in a certain way, then you're just using the what you've calculated already, right?
Mm-hmm.
So let's say you have like a 5x5 and you have to go through 2 comma 3, right?
Okay.
So that means after the first phase you must end up at 2 comma 3, right?
Mm-hmm.
So then how many ways are there to get to 2 comma 3?
All right, let's see that. Let's visualize that 5x5. Just copy and paste this.
Yeah, maybe for checkpoint we'll put like a 2 or something there, or -1.
Okay, so you said 2 comma 3. So
Sure.
row 2 and then index 3. So is that this one?
Right. So put like a -1 there.
Oh,
Or
negative
2,
1.
whatever.
I put it 2 over there. That's fine.
Sure.
So you're saying I have to go through this to get to the exit?
Yes.
Okay, so in that case, you still have ones across here because you can still go this way. Yeah, because wait, no, robot can only go right and down, right?
Mm-hmm.
So this one is 0 because you technically can't go here if you're at this index, at the last one of the first row. And then these ones are 1s, but these stay 0 because you can't hit that. So this is what it currently looks like, given that that's a checkpoint at the start.
Right.
Yeah, so basically the logic check is when we're building the initial starts, I think you scan you scan your row and column to see if there's a checkpoint, and then if there's a checkpoint, you stop at pending ones, I guess.
Well, okay, so you already know how to get to 2 comma 3, like, right? Because what you're doing right now is just the same thing on a smaller grid.
Yeah. hmm So okay.
So
So you're kind of saying like the checkpoint. You kind of view the checkpoint as like the exit and just try to build the path to the exit.
exactly,
Okay, I
exactly.
see. Okay.
So for you to reach a checkpoint, that has to be your exit at some point,
hmm
right? And so and
Also,
then
okay.
from
I
that,
see. I think what you're saying is you build the algorithm catering to the checkpoint first, and then once you get to the checkpoint, then you build the rest to the exit.
right, and which works for like one checkpoint, right?
Yeah. But then if you have multiple checkpoints, that's different. Would you build?
Right.
Would you call the algorithm multiple times, or does that not work?
Uh, so well, okay, there's now kind of two separate vantage points, right? One is it even possible? And if the answer is yes, then you call it multiple times.
I see. But one checkpoint is definitely possible. Two check
Uh, yeah, sure, sure.
two checkpoints is a different story per se. I'm not sure if I had to think about it. So if I had a negative one here, that's clearly possible because it's still in the same thing. But then if it was like some weird place, maybe not. I don't know. If like if you had a
Yeah,
checkpoint,
okay.
if you had a checkpoint there at 2 3, and you had a checkpoint here, that's not even possible to get? You can't. This is the impossible solution, right? Because to hit this checkpoint, you can't get to the other checkpoint anymore. You can only go to one of these checkpoints. So
Why?
basically, because you can only go right and down, right?
Okay.
So given that you cannot hit these two checkpoints are not like they're in like areas that they can't access each other basically. So the
Right.
checkpoints have to be on the same row or column for it to work, I think.
Well, not quite, but you're close.
Is that not quite what
What
else?
if your second checkpoint was at the very end instead of
Oh, right, I see. Okay. Oh, okay, I see. So it has to be same row and column or to the right of your row and to the bottom of your column. But yeah.
yeah, I mean you basically have it. It's basically for a valid set of checkpoints, you must be at least the same row and at least the same column.
Yeah. It has to be greater than or equal to. Yeah. If it's less than less than then it doesn't work.
All right. So what would happen if you gave you a jumbled set of checkpoints and asked you if it's doable?
Yeah, so basically you just scan for one checkpoint first, I guess, any checkpoint. And then you given that checkpoint, just check the other checkpoints to see if they're within range. So basically, I think you just one pass it, store the checkpoints into a like a I don't know like a set or something, a tuple set, which the indexes x y, and then just given that, pull one index out, check the rest of them to see if they all fit. If they all fit, then you're good. If they don't all fit, then you return false.
What do you mean by they all fit? So let's
So
say I
yeah,
gave you
so
two, three,
yeah, give me so 2 3 you said okay, and
two,
what
three,
else?
and as you mentioned, 4, 0, right?
4 0. Yeah, sure. Okay, so you're saying it's -1 here, right here. Okay, so yeah, so I'm doing a one pass on this matrix, right? So I'm gonna if I find an obstacle, I'm gonna store it. So I'm just gonna call it well not obstacle, checkpoint set or whatever equals set, and then I add to it. I'll add the indexes of that it's at. So it'll be like whatever, just row col. So my set at the end will look like I'll have a set of I think it's 2 3 and 3 0, right? So I'm gonna pull out. I don't know. It doesn't really matter which one. I just pull out So I pop from the set, or pop or I just peek at it, whatever. So I use given that first tuple that I pull out, I compare it with every other tuple in the set, and then they all have the coordinates of that have to match up. Like they have to work out. Basically, they have to be greater than or equal to this current one.
I see. That seems possibly inefficient. Is there a way to maybe rearrange it so that you just have to pass it through once?
Wait. Isn't this one pass? Or what do you mean?
You said you're checking against all other things and seeing if it's greater than or.
Yeah, is that bad? Because if there's like, because it's n by n grid, right? So let's say everything's a checkpoint. The worst runtime is just still n squared, right?
Right, but I'm saying you can do better if you rearrange it beforehand and then just go through.
Oh, I see. So like sort it first.
Yes.
Okay, yeah, that works. So if I sort it by the I guess row col. I guess yeah, just the standard Python sort. It would just sort by row. Then I think that should be fine. And you just pull out the first index and you compare it to the rest. But you still have to compare to all of them. I don't. How does that save runtime?
No. Now you process them linearly, right? You don't have to check anything. You just have to see if it's bigger than the last uh, column value, right?
Wait, wasn't that what I was doing before?
No, you said you're comparing against all the ones that are in there before, right?
I guess I'm not following because I was saying I'm comparing them to the set, right? But isn't that what you're doing too?
Right. No, then I don't understand your algorithm. How are you comparing to the set?
So yeah, so this set right now is 2 3, and then there's a 3 0, right? So let's say I pull out 2 3, then I compare 2 3 with 3 0.
Okay, then what do you get?
So yeah, and look at it. So it says 3 is greater than 2, which is fine, but 0 is less than 3, so you return false, basically, right there.
Okay, and then what happens if you have a third value, like like 3 1?
Okay, 3 1. Yeah, isn't that the same thing? I checked 3 1 against 2 3. Oh, I see what you're saying. Because if 2
Now
3.
you're comparing against everything.
Oh, you're saying 2 3 checks out, and I have to check the next column, right? Is that what you're saying? Yeah, just because 2 3 checks out.
If you don't sort it, then you're going to check every.
Yeah, you have to check everything. Yeah. If it's sorted, then you don't have to check once. Yeah. Okay, that's what you mean. My bad. Yeah. Sort it. It should be good.
Okay. Yeah. I mean, that's pretty much it.
Okay. Cool.
Yeah. It's pretty good.
Oh, so someone said DP. Oh my god. Yeah, that's how I feel.
Nice.
All right. Thank you.